Hello everyone, welcome to this week's MathCast podcast. Today we are joined by a Math Leap student. Today we are joined by Eva from Year 9 who will join us to discuss pi's history. Without further ado, let's get started. Alright, so before we start looking at the history of pi, we need to understand what it is and what it represents.
Pi is the ratio of the circumference and diameter, and it is approximately equal to 3.14.
So, time for a quick story. For over thousands of years, many mathematicians have attempted to extend their knowledge on this mysterious, irrational mathematical constant pi.
The most efficient way to calculate it for over 2,000 years was bisecting polygons. You would start with a circle, then draw a hexagon inside it, which has size length 1. This means that the diameter of the circle, which is any line going from one point on the circumference to another, while crossing through the middle point, is equal to 2. And the perimeter of the hexagon is 6. Which comes out from 6 sides, each length 1.
And since we know that the circumference of the circle must be larger than this hexagon, since the hexagon is inside the circle, we know that pi is greater than 6 over 2, or the circumference divided by the diameter, or also greater than 3.
Then we repeat this process on the outside of the circle. We draw a square that has a perimeter of 8, each side 2. Now we know that pi is less than 8 divided by 2, also known as 4. From this, we now know that pi is between 3 and 4, which might seem obvious to you now, but that's only because we know the actual value of pi, and since we have done the maths.
In order to improve on this method, Archimedes was able to go one step further. We can keep pushing this square and hexagon closer to the circumference of the circle to get a more accurate representation of the value of pi. The next thing to do was change the hexagon into a larger sided shape, say a 12-sided shape, a dodecagon. And the square also into a dodecagon, so the circle is in between these two shapes.
And they kept on doing that because more sides equals to higher accuracy. Many ancient civilizations, including the Egyptians, Chinese, Indians, and the Babylonians, who have all been dissecting polygons to improve this approximation of pi.
The number of sides these mathematicians have calculated is insane. At some point, it would look like the polygon with whatever large amount of sides is actually a circle because it had so many sides. But obviously, we know that it's not.
But then Sir Isaac Newton came along and changed the game. Keep in mind that calculus has now been invented, which allows infinite series, which can now be computed to find pi to extremely high accuracy. After this, there were no more bisecting polygons.
Pi is now used to test how accurate computers are. There are even competitions based on how many digits of pi you can memorize, the highest being 100,000 digits of pi memorized. Crazy. Anyway, back to our story. Pi was then proved to be irrational, then a transcendental number.
Which means that it will go on forever and it cannot be turned into a fraction. And it also has many uses in modern life. For example, it helps us understand our universe with greater precision and lead to a new angle notation known as radians, and has increased the number of significant discoveries in our physical universe. A common example of this being the construction of arches, bridges, and even buildings.
So as you can see, pi has infinitely many uses, an infinite history just as it has digits. Thank you for listening to this podcast. If you would like to know more about interesting topics such as how the world's largest hotel came to be, then make sure to check out this video too.